from power system, which is sag. So sag is the difference in level between points of support and the lowest point on the conductor. The difference in level between points of support and the lowest point on the conductor. So we have calculations of sag. So we are going directly into calculation. So first of all, we are going to calculate sag when the supports are at equilevel. So for example, we have point A and point B. They are on the same level, which means sag is the same, both point A and point B. And from A to the midpoint, we can call it length over 2. So it is the total length divided by 2, as you can see. Then from this level, we have the sag, and then we have Y, which is representing the force times the tension. So we can say that torque times that Y at that point P is equal to the weight of the conductor at the midpoint from 0 to P. So we have Wx dot times the distance, which is half the distance, which is x over 2. So we can find that T over y is equal to W, x times x is x squared all over 2. So we are interested in y, so we can divide both sides by t. So you can find that y is equal to W x squared over 2t. But at maximum sag, we can depict that y will represent our sag, and x over 2, which is the distance, will be the same as L over 2. So we'll get maximum sag when the distance there is L over 2, this one. So we can come back and substitute back in our, let's call this like equation 1. So we can substitute this there. So we'll have y, we replace it with S, which is sag, is equal to W. So we have x over 2 squared, which is the same as L over 2 squared all over t. So length over 2 times length over 2 is the same as length squared over 4. Substitute there. We'll find that W length squared over 4 times 2 t. This one will give us W length squared over 8 t. So sag is equal to WL squared over 8t. So this is the formula that we are going to use. Thank you.